Hello everyone and welcome to this new video. Today we are going to fine-tune large language model for text generation in Arabic language. Basically we have a dataset of Arabic quotes. I created the dataset and we are going to try generating tags using large language models. So this task is a little bit different from classification because the large language model each time will try to generate new tags. It doesn't have a set of labels that every time he needs to fit each quote under one of the labels. So it's going to be a little bit challenging and a little bit fun. So before we start, I need you to know that there are three ways to work with large language models. The first way is to pre-train them. So pre-training large language model, usually it's the process of training the model on a large corpus of text, usually containing billion of words, and not everyone can do this because it requires a lot of resources and it costs a lot of money. So this is the first way that we can use large language model. The second way is called retrieval augmented generation. Maybe you see this in many YouTube videos. It's called RAG, retrieval augmented generation, and it's basically about making the large language model answering your question based on external sources. For example, you give the large language model a book and you only want him to answer your question based on the information or the knowledge related to this book. This is the second way on how to work with large language model. The third way is fine-tuning, and it's the process of fine-tuning the large language model on a task-specific dataset. So for example, like in our task, we want him to generate tags for each Arabic quote. So we are going to give him the quote and the tags, and in this way he will understand his task and he will capture the style of the future generation answers based on the dataset he get fine-tuned on. So fortunately for us, this is not very demanding task. We can do it on our personal computers or even on Google Colab notebook. So that's what we are going to do. So we can jump over to our notebook. We are going to use four models. The first one is Red Pajama. The second one is Dolly V2, the OPT by Meta Facebook. The third one is GPT Neo. So this notebook that you see here is only for the Dolly V2, but we are going to do the same work for each of these models, and we are going to note the training time, the inference time, and the score to compare between them, just to see their capability for this task, text generation for Arabic language. And if you have dataset for French or maybe German or any other language, you can follow the same steps and try it for any foreign language. So let's start. We can see, by the way, the Hugging Face library. They have an open LLM leaderboard now, and we can see all the top models. So you may ask me why you didn't put the Llama 2 model here. So I prefer to create another video just for the Llama 2 model. So we are going to explore these models for Arabic language, specifically that these models are not very well exposed to Arabic language. For example, this Red Pajama is only on their website, it's only exposed to English corpus, English for the OPT and small amount of non-English. The Dolly is only English, and the language for the OPT Neo, it's English. All the models are under 3 billion parameters, so we can use them without any problem on the free Colab notebook. So the notebook is straightforward and it's easy to follow. Every cell is well commented. So here we start by getting the running time to track the time used for each cell of this notebook. Then we start by importing the necessary libraries, bits and bytes, transformers, PEFT, and the accelerate, and also the datasets to import our dataset to fine-tune the model. Then we start by initializing the transformer model and the tokenizer from the Databricks Dolly V2 3 billion model. It also configures, this code also configures the quantization with 4-bit weights and bfloat 16 data types for memory efficiency. Okay, so we choose to initialize our model with the 4-bit weights. So the 4-bit weights, it's basically the precision of the model weight of the model parameters. Okay, so our model has 3 billion, under 3 billion parameters, and each parameter is on 4-bit precision. Okay, so here's something to better understand. So the first thing is to load the active model in 4-bit precision. I took this from the Hugging Face blog. So if let's say that we have a model that has 20 billion parameters in 32 bits. So the size, the total size would be 80 gigabyte. If we go from 32 bits to 8 bits, we divide the precision of this model by 4, which means the total size of this model will be also divided by 4. So we have the same model with 20 billion parameters, but this time when we get it in 8-bit precision, it would be in 20 gigabyte of size. And in our case, we are working with 4 bits. So we need to divide also this model by 4. So in our case, this model would be in 10 gigabyte. Okay, so after that, the PEFT library, this is how it works. So we call them adapters. Adapters are the trainable weights. Okay, so we froze the 20 billion parameters. So in this case, we froze the majority of the model parameters, and we keep only a fraction of its parameters to be trainable. Okay, and these trainable weights, we call them adapters in the PEFT, using the PEFT library. Okay, so as we can see here, using this function that I created to print the number of trainable parameters and the total number of the parameter in the given model, we can see here that in our model we have 1.5 billion parameters, the total number of parameters. The trainable weights are only 2,621,000 parameter, and it represents only 0.17% of the trainable weights. So these weights here are only 0.17% of the total number of weights. Okay. Okay. So after that, we are going to use this code to retrieve the PEFT model using specified setting from the PEFT library, which is the LoRa alpha and the LoRa dropout. LoRa is low rank adapters from the PEFT libraries. And in case you are using the OPT model, I put it here. In case you are using the OPT model, you need to activate this line here. Okay. Otherwise, it works fine for the other large language models. Okay. So let's start by importing the pre-processing dataset. So as I said, these trainable weights, we need to feed them with the new data to capture the style of this new task. Okay, so these weights here are frozen, having the same, or let's say the main information of the model. We are only going to train 0.17% of the weights with our new data. So the dataset I have created, you can find it here on Hugging Face with this link here. It's called Arabic quotes, so we can see it here. So as we can see here, the dataset is relatively small, only 6,000 rows with 2 columns. The first one with the quote, Arabic quote, and the second one with the tags related to this quote. Okay, you can import it and use it from the Hugging Face library using this piece of code here. Okay, let's go back. After importing this dataset, we need to make a little bit of changement, because this dataset is good for classification, but here we are working with a generation task. Okay, so we need to put the quote with the tags in the same line. Okay, so we are going to concatenate both the quote and the tags, and it will go like that. Quote, I give them the quote, dot, tags, and the related tag. Okay, we did that for all the data set using this piece of code here. We did that because when we are going to ask the model, it's a generation task, so we are going to ask him like that. We give him the quote, and then we give him the tags, and from this point it's for him to generate the rest. Okay, that's how it works. So here we are going to start fine-tuning the model using 20 steps, and we can see that we have training loss that dropped from 3 to 1.99, which is not bad in 20 steps. And the training, we should say that it took 1 minute 4 seconds for training, so it's pretty fast. It's pretty fast because we are not training the whole parameters of the model. We are only training the adapters using the PEFT library. And also it's quantized, it's on 4 bits. The precision is pretty much lower than the original precision. Okay, so for inference, I prepared these 10 quotes. It's in Arabic, and their respective tags. Okay, so for each quote, their respective tags. So for inference, we are giving the model the quote, the Arabic quote, and then we are stopping just after the tags. Okay, so for him, he will continue by generating the rest of this sentence, following the same style that he has been fine-tuned on. So he will generate the tags. So for this inference task, the model took 32.6 seconds, which is also fast. And here's the raw results. So we can see some bugs or some, for example, he gives the tag, then he starts over with tags, or he starts over with an empty list or something. So I had to clean the generated tags. And here are the final results. So for each quote, there is the Dolly V2 generated tags. He gave tags. Sometimes the tag doesn't make any sense. We can clean it, or maybe the model, as we said, the model is not very powerful, and we can see that, but he is doing a great job by generating these tags. So for the accuracy score, I used the Jacquard similarity between the two lists of Arabic strings. So the first list is basically the generated list, and the second list is the respective tags that we fixed at the beginning. So the accuracy score gave us 0.25, which is not very good, because the best is to reach 1, and the closest to the 0, it's a bad result. Okay, after that we are going to try to host this model on the Hugging Face hub. All you need to do is to run this cell here, and you need to pass your token. So to do that, let me show you how. You go to your Hugging Face portfolio, you go to settings, and then you go to access tokens, and you copy your token. And if you don't have one, you create a new token. Okay, so you copy this token, you paste it here, and as you can see, they will say that the token is valid, permission to write, your token has been valid in your configuration, get credential helpers. Okay, so after that, by using model push to hub, we are going to push. This is the name we chose for our model, is Dolly V2 3 billion Arabic tags, and it's going to be if you want it to be private, you are going to activate this line here, but we want it to be public, so we run this. So with running this cell here, we used the model.push2hub to push our model with the name that we chose to our Hugging Face repository, and we can just verify by going back to our Hugging Face repository and see if we have this model here. So yes, updated 4 minutes ago. It's Databricks Dolly V2 Arabic tags. To use this model, you need to go inside and use impeft. Okay, so you copy this snippet here, code snippet here, and you're ready to use it. Okay, so let me show you how. Using that code, that snippet here. So the utility of this is if you are very satisfied with your model results, you can do that to use it for inference and avoid fine-tuning your model each time you want to use it. So that's better, and you can share it with your colleagues, or you make it open source for everyone who wants to use it. So it's very helpful, and this is free to use, so you're not paying anything for hosting your model. So while this code is running, let me go and take an Arabic quote. For example, let's say this one. Happiness is not something ready-made, it comes from your own actions. السعادة ليست شيئا يحصل بسهولة فإنها تأتي من أفعالك. And let's see what tags will our model generate for this quote. Okay, so batch, tokenize this, return answer. Okay. So now by running this code here, we will see the result generated by the model that we already hosted. So quote, and the tags are af'al, af'al, af'al. So basically the model is a little bit hallucinating, but you get the idea. So af'al in English means actions, but okay, so the model is generating our tags. It needs some cleaning, and as I said, the results are not very good due to the model lack of exposure to Arabic language, and also because the model is relatively small, only 3 billion parameters. So the goal from this notebook is only to know how to use large language model, how to fine-tune them, and how to get inference by pushing them to the Hugging Face repositories and use them again. So I hope you liked this tutorial and you find it very informative. You can find more about this tutorial in my blog post here. It's well explained and I showed all the details and results. You can get this code also, and see you in the next tutorial. Thank you very much. Goodbye.